begin with the next chapter, which is chapter number 4, differential equation. So I think out of the first 3 chapters, this will be the shortest and very easy. So we'll begin with the definition. So definition of a differential equation is an equation containing derivatives of a function is basically called as differential equation. So what are the types of differential equation? The first is the ordinary differential equation, which involves only one independent variable, and the partial differential equation, which is second type, which involves two or more independent variables. So what are the examples? First we'll see for the ordinary differential equation. We are very much familiar with the radioactive decay. Okay, so you have come across the equation which is called as dN by dt, okay, is equal to or proportional to n, correct? Then we use the word that dN by dt is equal to minus lambda n. As this is decay, we have put a minus sign, and lambda is a constant. Similarly, we come across the simple harmonic motion equation, okay, which is nothing but force, okay, force is equal to ma, okay, and we use the word that force proportional to x, clear, and that x is nothing but a constant. If at all I remove the proportionality constant, it's minus kx. So therefore we can always use the word m d2x by dt square, because m is this, is equal to minus kx. This is my again a differential equation, okay, of the simple harmonic motion, correct? Then if at all I want to define or give an example of, these are the examples of ordinary differential equation. To give the example of partial differential equation, what will I say? The simple example is dabba square psi by dabba x square is 1 upon c square dabba square psi by dabba t square. This is a one-dimensional wave motion equation, correct? Along with that, one more thing we have in TYBAC physics, which is del square psi is equal to 0. So these examples will come under the partial differential equation, which involves two or more independent variables, correct? Now, after knowing this simple definition of differential equation and these two basic types, already we have discussed a lot about partial differential equation. So we'll just see what are the ordinary differential equation, in which we need to know first what is called as the order of differential equation, correct? So how will you define the order? First, order of a differential equation basically is the order of the highest derivative it contains. So I'll mention over here the highest derivative it contains. Okay, now means what? I use the word only if at all I have the equation contains dy by dx, it will be first order, correct? Dy by dx. Then if at all I say d2y by dx square, this is the second order differential equation. When I say d cube y by dx cubed, it will be third order, and so on. If at all I say d4y by dx raised to 4, this is the fourth order. So depending on what it is there in your equation, it will be easy for us to mention the order of the differential equation, correct? So it's not at all difficult to talk whatever equation it consists of. Just check the highest one. So this is 1, 2, 3 and 4. These are the order of a differential equation, okay? Afterwards we will define what is the degree of differential equation. Now basically power of the highest derivative, we'll define it over here, power of highest derivative after differential equation has been rationalized, because until unless you do the rationalization, it is not advisable to define the degree of the differential equation, correct? So now what do you mean by this rationalization and all, that we will see in this first example. Okay, so my first example is d square y by dx cube, correct, raised to d square y by dx square, square, raised to cube plus dy by dx plus xy square is equal to 0. This is the example given to you. So over here the question is find out the order and degree of the differential equation, correct? So this is d2y by dx square, this is dy by dx, and this is y. So obviously the order over here is, okay, the order over here is 2, because this is the highest, okay, and if I need to check the degree, so degree will be 3, correct? So order is 2, degree is 3. Power of the highest derivative, this is the highest derivative, d2, this is d1, and this is only y, correct? There is no derivative. So over here this is the way we can simplify, right? Now we'll take the little different example. Okay, so in this example we have to check d cube y by dx cube, first example. Second example, plus x dy by dx raised to 3 by 2 plus x square y is equal to 0, correct? Now my first job is to simplify this, then only I will be able to give the order and degree both for this equation, correct? So simplify this, what will I do? I will take this term on one side and I write x dy by dx raised to 3 by 2 is equal to minus d cube y by dx cube plus x square y, correct? Now my job is to square both sides, by which it will be still more simpler for me to get the order and degree easily. Okay, so I'll say squaring both the sides, correct? What will I get? I'll get x square dy by dx, this is 3 by 2 and I am squaring it, so it will get cancelled, is equal to d cube y by dx cube, correct? I need to square this term completely, so this is square plus twice d cube y by dx cube into x square y plus x raised to 4 y square. Okay, now somehow I have got the term little in a better fashion, so now I can say very easily that d cube y by dx cube square plus twice d x square y, I'll write first, this term I'll write first and then write d cube y by dx cube minus x square dy by dx cube plus x raised to 4 y square is equal to 0, right? Now this equation is now in a properly simplified manner. So this is d cube y by dx cube, this is square, this is d cube y by dx cube raised to 1, this is dy by dx, and so on, correct? So now we are in a position to define what is called as the first order and then the degree, correct? So over here, what is the highest order? Highest order over here is 3, correct? So my order over here is 3, so I'll say order is 3, correct? As far as degree is concerned, how much is the degree? This is the degree is power of the highest derivative after differential equation has been rationalized. So this is the rationalization is done, so this is my highest, so here I can say the degree is 2, okay? Order is 3, degree is 2. So there will be many examples in the exam also, in the examination also, where you need to check the order and degree of a differential equation. Correct? The third thing we will define, which is called as linearity. Now what do you mean by linearity? A simple concept. If the dependent variable and its derivative appear in the first power and no product term of dependent variable and its derivatives occur in the equation, that is the meaning of differential equation. Now what do you mean by, I'll just give an example. Suppose I have X equation d square y by dx square plus 2 dy by dx plus y is equal to 0. Correct? Dependent variable and its derivative appear in the first power. Correct? First power, and no product term of dependent variable and its derivative occur in the equation. So this is the way I have there is no power given over here. It is just d square y by dx square plus 2 dy by dx plus y is equal to 0. This is my linear equation. But to define nonlinear equation, what will I say? Non-linear equation, I'll say dy by dx cube plus d2y by dx square is equal to 0. This will be my non-linear differential equation. Correct? The fourth definition, first definition we have seen the order, second is degree, third is linearity, and fourth is the homogeneity. Homogeneity, homogeneity of differential equation. Now what do you mean by homogeneity of differential equation? A linear ordinary differential equation of general order, okay, has the form, correct? Suppose I write the equation ANX dny by dxn plus an minus 1 of x dn minus 1 y by dxn minus 1, correct, up to the last term, which is a1 of x dy by dx plus a0 x y is equal to f of x. Correct? Now if f of x is 0, this is the equation given to you, and if f of x is 0, then the equation is homogeneous. Otherwise, it's, if there is some value given over here, then it is, if fx is not 0, then non-homogeneous or inhomogeneous. Fine. Suppose example for homogeneous. Homogeneous is d square y by dx square plus 6y dy by dx plus 5y is equal to 0. This is homogeneous equation. And suppose I say d square y, same equation. Suppose d square y by dx square plus 5 dy by dx plus y is equal to sin x. This will be non-homogeneous, and this is homogeneous. Right hand fx is equal to 0, homogeneous. Fx is not 0, then non-homogeneous. Correct? So this is the way we will solve few problems in the next lecture. Along with that, there is only a simple topic left, that also we will cover in the next lecture, which is concept of singular point. Okay, so singularity, in short, we will be discussing it in the next lecture. So go through it. Any difficulty, feel free to ask. So in this today's lecture, we have discussed definition of differential equation, types of differential equation, and the four things, which is order, degree, linearity, and homogeneity. correct? So after knowing these 4 things, we will take at least 2 to 3 problems and then go to the concept of singularity, which will be another 30 minutes lecture. I will be able to take it to complete this chapter 100%. Okay, thank you very much.